Right now, Europe is living through the direct result of what meteorologists call a locked-in weather pattern, a state where the normal ever-shifting flow of the jet stream essentially breaks down and stops moving weather systems along in their usual rhythm, trapping an entire continent under the same conditions for weeks at a time. In late June, a powerful blocking high-pressure system parked itself over Western Europe and simply refused to move, and the result was described by the World Meteorological Organization as one of the most intense and widespread early summer heat events on record, with more than two-thirds of Europe's population experiencing temperatures above 35 degrees Celsius. Spain's Fabra Observatory in Barcelona, a station with more than a century of continuous weather data, recorded 40.5 degrees Celsius on July 8th, the highest temperature in its entire historical record. Today we are going to break down exactly what happened to Europe's weather system, why a jet stream pattern breaking down matters so much more than a normal heat wave, and what scientists say could still be coming before this pattern fully resolves. No exaggeration, no doomsday guessing, just the data, the atmospheric science, and the real stakes. Drop a comment right now. Have you experienced this summer's heat firsthand anywhere in Europe? Tell me where you were and what it felt like. So many of you write in from across the continent, and I read every single one of those comments. If you want to know the moment this pattern shifts again, subscribe right now. It costs nothing, and a thumbs up tells the algorithm to put this in front of people who genuinely need to see it. Let us get into it. To understand why meteorologists describe this pattern as a genuine collapse rather than simply a hot summer, you first need to understand what the jet stream normally does. The jet stream is a fast-moving river of air high in the atmosphere that typically flows in a wavy but continuously shifting pattern across the mid-latitudes, and that constant shifting is exactly what usually keeps weather moving, pushing hot spells through in a matter of days before pulling in cooler air or rain from the Atlantic to reset conditions. A blocking pattern happens when a large area of high pressure becomes so strong and so stable that it essentially dams up this normal flow, forcing the jet stream to bend dramatically around it rather than pushing through, and the high pressure system then sits in place for days or even weeks, trapping whatever air mass happens to be underneath it. This is precisely what settled over Western Europe heading into late June, described by forecasters as a textbook locked-in weather pattern, with the core of the heat dome parking directly over Germany and stretching toward Poland and the Baltic states, delivering air temperatures running 16 to 18 degrees Celsius warmer than normal at the levels meteorologists use to measure the strength of a heat dome, combined with relative humidity dropping below 25% in the driest zones. The numbers this pattern produced were not marginal records. They were the kind that rewrite entire national datasets. France recorded temperatures above 40 degrees Celsius 114 separate times between June 17th and June 29th, surpassing the previous national record of 87 instances set all the way back in August of 2003, a benchmark that had stood for more than 2 decades. Germany broke temperature records for 3 consecutive days, with the town of Caution near the Polish border reaching 41.7 degrees Celsius. And across the country, a total of 252 individual weather stations recorded all-time temperature highs during this single event. According to the Copernicus Climate Change Service, June 2026 became the hottest June ever recorded for Western Europe specifically, with an average regional temperature of 20.74 degrees Celsius, 3.05 degrees above the historical 1991 to 2020 baseline for the month, itself surpassing the previous record which had only just been set the year before in June 2025. Globally, June 2026 ranked as the second warmest June in the entire modern satellite era, driven in significant part by the highest sea surface temperatures ever recorded for that month, since warmer oceans feed directly into how much heat and moisture the atmosphere above them can hold, and eventually redistribute onto land. This is where the phrase, "what happens next," genuinely matters, because a blocking pattern this powerful does not simply switch off once the immediate heat wave ends. It reshapes conditions on the ground in ways that set up the next event. Meteorologists tracking the pattern through July have warned specifically that after a brief, partial cooldown as the Atlantic pushed slightly lower pressure toward the British Isles, the same underlying mechanism that built the June heat dome remained capable of rebuilding a second heat dome later in the month, precisely because the broader atmospheric configuration driving the blocking pattern had not fundamentally changed, only paused, and the consequences of this pattern extend dramatically beyond simple discomfort. France issued a widespread amber alert, the country's second highest heat warning level, paired simultaneously with a high wildfire danger designation because of the compounding effects of drought. Extreme temperature and critically low humidity, and the heat that began in June has continued fueling devastating wildfires across France and the Iberian Peninsula well into July. Extreme, sustained heat like this does not simply threaten human comfort. It tests the physical limits of infrastructure that was engineered around historical climate norms rather than repeated multi-day extremes. very hot. Less dense air reduces aircraft performance during takeoff, forcing airlines to extend runway distances or restrict payload at airports never designed around these temperature thresholds. Railway tracks are built with specific temperature tolerances, and when steel expands beyond those limits under extreme heat, operators must impose speed restrictions or risk the track physically buckling, meaning heat waves can disrupt entire rail networks even without a single drop of rain or flake of snow involved. Power grids face similar strain, since nuclear power stations and other thermal plants were designed around reliable access to cold river water for cooling, and when river temperatures themselves climb during a prolonged heat dome, generating capacity can be forced to reduce output at exactly the moment air conditioning demand across the grid is at its highest. Agriculture faces perhaps the most cumulative pressure of all, since crop and livestock systems were planned around seasonal heat patterns rather than repeated, multi-day extremes paired with tropical nights that never allow temperatures to drop enough for meaningful recovery. This is the honest scientific framing worth understanding. This particular event does not mean every future July in Europe will bring the same catastrophic disruption. But it does mean that each new heat wave under these conditions now tests considerably more than just the thermometer. It tests power grids, hospital capacity, crop resilience, tourism-dependent economies, labor safety regulations, rail networks, schools, housing, and water management systems simultaneously, all interconnected systems that can each independently fail under sustained strain, even if no single one reaches a dramatic breaking point on its own. The World Meteorological Organization has been explicit that this is part of a broader trend it expects to continue, stating that extreme heat is expected to occur with increasing frequency, intensity, and duration, according to assessments from the Intergovernmental Panel on Climate Change. And WMO, along with its member states and partners, are actively mobilizing early warning systems and coordinated heat health action plans specifically to reduce the human toll and economic disruption these events cause. If you live anywhere in Europe, here is what is actually worth understanding heading into the rest of this summer. Take amber and red heat alerts from your National Weather Service seriously as genuine operational warnings rather than routine notifications, since France's amber alert during this event was paired directly with active wildfire risk, meaning the danger extends well beyond simply staying hydrated indoors. Check on elderly relatives and neighbors directly during any multi-day heat event, since a significant share of heat-related deaths during events like this one involve older adults living alone, and cumulative heat stress compounds, specifically when overnight temperatures fail to drop enough to allow the body genuine recovery between consecutive scorching days. If you're traveling by rail or air anywhere across the affected regions during a heat alert, build extra buffer time into your plans, since speed restrictions on tracks and payload limitations at airports are a documented recurring consequence of exactly this kind of sustained extreme heat, rather than a rare or isolated inconvenience. And if you live in a region under an active wildfire danger designation, know your evacuation route and stay informed through official regional alerts, since dry vegetation combined with erratic winds during a heat dome can turn a contained fire into a fast-moving emergency with very little additional warning. Final thought. What collapsed in Europe this summer was never simply a stretch of hot weather. It was the normal, self-correcting rhythm of the jet stream itself, replaced for weeks at a time by a blocking pattern powerful enough to rewrite national temperature records across multiple countries simultaneously and stress test infrastructure systems that were never engineered around conditions this extreme or this sustained. The scientific message from the agencies tracking this event is not that catastrophe is guaranteed every summer going forward. It is that the margin these systems were built with is shrinking, and each new locked-in pattern now carries the potential to affect millions of people through channels far beyond the temperature reading on a thermometer, from the trains they ride, to the food grown in the fields around them, to the power keeping their homes livable through the worst of it. We will keep tracking every WMO update, every Copernicus temperature record, and every shift in this pattern as the rest of the summer unfolds. Subscribe so you do not miss it, and leave that comment below. Has this summer's weather in Europe genuinely surprised you compared to summers you remember growing up? Because for millions of people across the continent right now, this is not a distant statistic, it is the reality of the season they are living through today. Let us get this one to 5,000 likes. See you in the next one.